Now, we're going to go one step further and work with equations where you have to factor them before you can apply the zero factor property. And so in this segment, we'll just go through examples where we factor and solve equations. Let's begin with a review of our method. What we're going to do is, first of all, get our problem, whatever it is, get our equation equal to 0. Then we factor. We set each factor equal to 0. We solve each of these mini equations that we now have for whatever our variable is. And we check in the original equation. Suppose you have the problem negative 2n squared minus 10n plus 12 equals 0. First step, get it equal to 0. I'm going to rewrite it over here so I have room to write out our steps. Step 1, get it equal to 0, done. Came to us that way. Step 2, factor. Well, I'm going to use a product sum table on this, and my product is going to be, oh no, I'm not either. I'm going to be on my toes, and notice I could take out a negative 2. Going through my questions, greatest common factor, yes, there is one. So take out a negative 2, and now we have n squared plus 5n. When you pull out negatives, you have to remember to change your signs. Minus 6 equals 0. Neat trick. If I have just a number out in front, doesn't work if there's a letter. No letters, just numbers. I can divide each side by negative 2, and that negative 2 is gone. Now what I have is n squared plus 5n minus 6. Anytime you can pull out a constant, a numerical coefficient, you can divide it away and simplify your problem tremendously. I did not need to write those parentheses, but that's okay. They don't harm anything. So now I can go with the trinomial. I'm not going to factor by grouping. So we have a trinomial. Our product is going to be negative 6 times 1, so a negative 6. And our sum is going to be a positive 5. This one's pretty straightforward. To get a negative 6, adding to 5, I'm going to need a 2 and a 3. No, I'm not either. I'm going to need to think in terms of opposite signs. I'm going to need a 6 and a 1. 6 and a 1, and I better make the 1 negative. And that'll work, because 6 minus 1 is positive 5. I don't have to go through the whole renaming process because I have plain old n squared. So this should factor to n plus 6 times n minus 1 equals 0. And I can check that quickly with a FOIL. N squared outside minus n plus 6n gets me a plus 5n minus 6. And I recommend you do that. We have factored it. Our next step is to set each factor equal to 0. So n plus 6 equals 0. N minus 1 equals 0. Solve each of those. Subtracting 6, we have n equals negative 6. Adding 1, n equals 1. And I will leave it to you to check it in the original. Our solution set is negative 6 and 1. Oftentimes books will present their answers to you by writing out the solution set in a set notation. Now, we're going to look at what happens when you have to rearrange your equation first. It doesn't come at you so neatly already set equal to 0. So we'll look at an example with that. Let's solve 9a times a plus 1 equals 4. First step, get it equal to 0. I'm going to have to multiply this out, and then I'll have 9a squared plus 9a equals 4. Going to have to subtract 4 from each side, so I will have 9a squared plus 9a minus 4 equals 0. I'm going to factor this. There is no greatest common factor. I'm not going to factor by grouping. I am looking at a trinomial. My product is going to be a negative 36, and my sum is going to be a positive 9. What can I use for that? 3 and 12. And I want the 3 negative, and those will add up to a positive 9. So I'm going to rename the 9a as a negative 3a plus a 12a minus 4 equals 0. Factoring by grouping, let me take out a 3a, and I'll be left with 3a minus 1. And from here I can take out a 4. I'm going to bring down the addition symbol. 4, and I'm going to have a 3a dividing by 4 minus 1. The insides of the parentheses are identical, so life is good. Pulling out the 3a minus 1, we'll be left with 3a plus 4 equals 0. It's factored. Yay. Now, next step, we're going to set each factor equal to 0. So, let's do that. And we'll have 3a minus 1 equal to 0. 3a plus 4 equal to 0. Adding 1 to each side, 3a is equal to 1. Dividing by 3, a then is equal to 1/3 is one solution. The other solution, 3a is negative 4, divided by 3, a is negative 4/3. And so our solution set, and again you can check that in the original, is a negative 4/3 and 1/3. Both of those satisfy the condition that when you substitute them in for a, your equation is equal to 0.